So the question is, what is the balance equation for this reaction by identifying the mole ratio between hexane and oxygen, between hexane and carbon dioxide? So what I assume this to be is that you have a combustion reaction with hexane, and so you'll have hexane plus oxygen gives you carbon dioxide and water. So that's the classic combustion reaction. So first, in order how to tackle this problem, you need to know what hexane is. So using the prefixes methyl, ethyl, propyl, butyl, hept, and hex, we can see that hexane has 6 carbons. So we have 1, 2, 3, 4, 5, 6. And then each carbon on the end will get 3 hydrogens. Each carbon in the middle will get 2 hydrogens. So that's how we have, so we'll have 6 carbons. 2, 3, 4, 5, 6. That's where you get the hex. Ane is because it's a alkane. And then the 14 hydrogens are from the end. So that's how we get the molecular formula for hexane. So then we go down and write our combustion reaction. So we got C6H14 plus oxygen. So oxygen is diatomic. And that will go to carbon dioxide plus water. So from this point, then we have to balance the equation. So we have the left side of the reaction, and then we have the right side of the reaction. Go ahead and write that in. And then we'll go ahead and balance each element. So first off, we'll start with carbon, then we'll do hydrogen, and then I like doing oxygen last, and it's kind of like a check. So we'll do oxygen last. So carbon, on the left side, we have 6. We'll go ahead and use a different color. So on the carbon, we have 6 on the left. So that means we're going to need 6 on the right. So we're going to put a 6 here. And that way we'll get a balanced equation for carbon. I'll go ahead and use purple. And on the left of the side, we have 14 hydrogens. So that means we're going to need 14 hydrogens on the right. So in order to do that, I'll put a 7 here. That'll give us 14 hydrogens on the right. And now this comes the check. Let's go ahead and use red. Now for oxygen, we have 2 on the left. And on the right, we have 12. And we have 7. So we have 19 on the right. Now, this doesn't make sense because we can't get 19 on the left because we have a diatomic molecule. So this is the trick that's commonly used. So go ahead and put 19 divided by 2. And because this is diatomic, that'll give us 19 oxygens on the left as well. And so if you wanted to make this a whole number, all you have to do is go ahead and multiply everything by 2. So this becomes 2. This becomes 19, this becomes 12, and this becomes 14. So if you wanted to balance it this way, that's also like that, and that becomes balanced. So then we have the mole ratio. So now that we have our evenly balanced equation, so I'll go ahead and erase all of this and get it all nice looking. So we got 2 carbons, 19 oxygens. I believe we said we had 14 carbon dioxides and 12 carbon dioxides and 14 waters. So now that we have this, we can find our mole ratio. So the mole ratio between hexane and oxygen would be 2 to 19. So for every mole of hexane, we have for every 2 moles of hexane, we have 19 moles of oxygen. And then the mole ratio between hexane and carbon dioxide. So for every 2 moles of hexane, we have 12 moles of carbon dioxide, and we can rewrite this as 1 to 6. So we divide by 2. That's how we get a 1 to 6. So we have a 2 to 19 mole ratio of hexane to oxygen, and we have a 1 to 6 for hexane to carbon dioxide.